to the Comptia Network Plus course, Virtual Wire versus Routed. Firewalls can control communications between segments by controlling traffic between layer 3 segments, routed approach, or by a process called virtual wire. In this approach, the firewall is connected between a trusted and untrusted section of the network, as shown in figure 15.7, to the devices connected to the firewall. In this figure, a switch and a router appears that only a single wire is connected between them. Our virtual wire firewall interfaces do not need IP addresses. Security zones are defined on the physical interfaces of the virtual wire pair. Virtual wire does neither routing nor switching. It examines the traffic flow to perform a deep packet inspection and enforces the firewall policy. Zones. A zone is an individual area of the network that has been configured with the specific trust level. Firewalls are ideal devices to regulate the flow of traffic between zones. If you look back at figure 15.3, this provides a good example of how zone levels could work. The internet would be a zone with no trust or a low level of trust. The DMZ located between the internet and the internal network could have a medium level of trust. The computers on the internet would all be within a high trust zone. The higher the trust level, the less scrutiny you place on data coming from a computer in that zone. Another way to look at zones is to understand how Internet Explorer deals with them. Figure 15.8 shows you what the Internet Options Security tab looks like. On this tab you can see that there are 4 zones for which you can configure security levels: Internet, Local Intranet, Trusted Sites and Restricted Sites. There are 3 default security levels for the Internet: high, medium, high and low. Don't get this confused with the trust levels I talked about in the previous paragraph that are basically opposites. If the security level is set to high, it means you have low trust. A good way to ensure some security through your browser is to set the security level to medium, high or high and leave it there. If there are sites that you download from frequently that you trust, then you can put those sites into the trusted zone. Click Trusted Sites and then click the Sites button to get to the screen shown in figure 15.9. Finally, you can customize the security level of any zones by clicking the Custom Level button near the bottom of the Internet Options window. This will take you to a screen similar to the one shown in figure 15.10. Within the custom settings, you can specify behavior for .NET Framework components, ActiveX controls and plugins, download scripting, user authentication and several other options. Most of the options have choices to disable or enable or prompt you if you want to continue with the operation. Intrusion detection and prevention systems. If someone has broken into your network, how would you know? I mean, it's not like you're going to find broken windows or the door left wide open, right? Although it's true that you won't be dusting for prints. Bad guys who break into networks still leave clues behind that can help you sleuth out their identities as well as how they gained access. A great tool for doing network detective work is known as an intrusion detection system, IDS. Firewalls are designed to block nasty traffic from entering your network, but an IDS is more of an auditing tool. It keeps track of all activity on your network so you can see if someone has been trespassing. Because the technology behind IDSs is fairly new, People are busy developing ways to combine IDS technology with existing firewalls. There are two kinds of IDSs that can detect attacks or intrusions. The first, often referred to as a misuse detection IDS, MDIDS, is based on the signature of an intrusion, and it works by looking for fingerprints. That's right, I said fingerprints, which in this case means strange or abusive use of the network. The IDS sends up an alarm only if it recognizes the fingerprints typical of attackers. The second approach looks for anomalies in the network activity, or anomaly detection IDS, ADIDS. And ADIDS basically watches for anything out of the ordinary. If it discovers fingerprints where there shouldn't be any, it'll send out an alert. And a really cool feature is that it's known as a smart system because it learns to go by keeping track of and building a history of network activity from nodes to which you can compare unusual activity. Most IDSs today are a combination of two types of detection systems. Figure 1511 shows an MDIDS in action. An IDS system is made up of several components, including one or more sensors to detect events, a console to control and configure the sensors and monitor events, and a database that records the event. These three elements can all be on the same device, or they can be implemented on multiple devices. The two most common types of IDS implementation are network-based and host-based. Network-based IDS, by far the most common implementation of a detection system, is a network-based IDS and NIDS, where the IDS is a separate device attached to the network via machine like a switch or directly via a tap. Some IDSs are even capable of attaching to the network both outside and inside the firewall. This gives you the best security because you can see what's happening out in the wild and really nail exactly what's getting through your defenses. Figure 1512 gives you an example of what a typical IDS setup would look like. When your IDS detects an intrusion, it'll respond to either passively or actively. Passive responses are the easiest to configure and include the following: logging. All activity of the intrusion is logged. The information is gathered can be used to foil attacks of the same type. Intrusions should always be logged. Notification. When an attack occurs, an IDS can send an alert to one or more administrators. Showing I'm not kidding you about this one. You can sometimes just ignore the attack because it's possible it won't affect your network. For instance, if someone launches an attack designed to cripple a Microsoft Exchange email server at a network that's running Lotus nodes, you're all good. So why waste your time doing anything about it? I would recommend recording the event though. Active responses mean taking immediate action. When an IDS moves to prevent an attack, it's often called a reactive system or an intrusion protection system. Here are three common active responses. Changing network configuration. Let's say an attack comes in on port 21. Your IDS can close the port either temporarily or permanently. The downside is that if the IDS closes ports, your legitimate traffic can get through either, but it will definitely stop the attack. Figure 1513 shows an example of closing port 80 HTTP for 60 seconds. Terminating sessions. When an IDS detects an attack, it can force all sessions to close and restart, which will affect and delay legitimate traffic too, but not for long. Deceiving the Attacker. This one's the most fun because it tricks the bad guy into thinking their attack is really working when it's not. The system logs information trying to pinpoint who's behind the attack and which methods they're using. This response requires something called a honeypot, typically a server or group of servers called honeynets, or maybe even access points to which the hacker is directed, is intended to keep their interest long enough to gather enough information to identify them and their attack methods so you can prevent another attack in the future. Figure 1514 demonstrates this. Host-based IDS. In a host-based IDS, software runs on one computer to detect anomalies on that system alone by monitoring applications, system logs and event logs, not by directly monitoring network traffic. Systems like these are typically implemented on servers because they're bare to manage if spread across several client computers on a network. Plus, if the IDS database is on the local computer and its data becomes compromised by an attack, an IDS could become corrupted too. Vulnerability scanners. One of the most effective ways to determine if security holes exist in the network is to think like an attacker and attack your own network. In that case, why not use the same tools that the hacker might use to identify your weakness? For example, if I wanted to verify the proper application on some ACLs to a firewall, I could do so with scanning services supplied by a vulnerability scanner. In the following sections, I'll cover two of the most widely known and effective programs that can be used for this purpose. Nessus. Nessus is a proprietary vulnerability scanning program that requires a license to use commercially, yet is the single most popular scanning program in use. It normally is executed from the command line because it can thus be included in batch files that can automate its operation on a schedule. Its output can be reported in a variety of formats including plain text, HTML and XML. It operates by performing a port scan and then follows up with more specific tests and scans based on the open ports. It can identify a wide array of weaknesses including the following: unsecured access to sensitive data on the system, misconfigurations like open email, relay and missing patches, password issues such as the use of default passwords, common passwords and blank passwords on system accounts. Nmap. Network Mapper Nmap was originally intended to simply identify devices on the network for the purpose of creating a network diagram. Its functionality has evolved, however, and now it can also do the following: perform port scanning, identify versions of network services in operation on the network, identify operating systems. It can be used from the command line as with Nessus, but it can also be used with web-based interfaces to be controlled remotely. Unified Threat Management UTM. Unified Threat Management UTM devices perform multiple security functions within the same appliance. Network filtering, network intrusion prevention, gateway antivirus, gateway anti-spam, VPN, content filtering, load balancing, data leak prevention, on-appliance reporting. While the advantage of unified security lies in the fact that administering multiple systems is no longer necessary, some feel that a single point of failure is created by creating multiple layers of devices is a more secure approach. So I'm going to leave it here today for this video. If you like listening, please consider sharing and subscribing. Thank you.